Hello, and thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to Chemistry Connections. My name is Devon Ennis, and I'm your host for episode 23, called The Chemistry of Candles. Today I'll be discussing what happens to candle wax when it's lit and how candle wax is made. So I'm going to start off with some background first. The earliest surviving candles were found in China from 200 BC. And unlike candles from today, they are made from whale fat, which I thought was very interesting because I never heard of that before. And moving on towards the Middle Ages, tallow candles became the most popular type, and they are made from fatty glycerides. And then by the 13th century, candle making actually became a craft in France and England, as making candles and using them started becoming even more popular. Today, we obviously have a very different use for candles because we have electricity, so there isn't any use as a light source from candles. I'm pretty sure you know, but they're mostly just used for like the scent or just to look nice. There's a few different kinds of candles. The first are tallow-based, like I mentioned from the Middle Ages, and the type used today is paraffin-based. There's also soy wax, beeswax, and liquid wax. You can find a lot more information about the types of wax if you're interested, but I'm focusing more today on what happens to the candle wax when the wick burns and how the wax for candles is made. In the first part, behind chemistry for candles, I'm going to be talking about the wax burning from the wick. So to start off, paraffin wax, which I said before, is the most common type of wax used in candles today. It's a heavy hydrocarbon and it's made from crude oil, which is also used for things like gasoline. When the candle's lit, the wax obviously melts around the candle first. What happens is the wick absorbs the liquid and pulls it up towards the flame, and the heat vaporizes the wax and it evaporates into wax vapor. Looking at a candle that you would burn out, like when you're done using it and just putting it away, you can see a white stream of smoke after. I've always wondered what that was, and I actually came across it while I was researching for the podcast, and it's the paraffin vapor that condenses into visible form once the candle is blown out. And that also explains why you can relight the candle by putting an open flame near the stream of vapor. To go into my next point, I'm going to be talking about how specifically paraffin wax is made. The first step is to use slack wax as a feedstock. And the whole point of this little thing I want to talk about, this little experiment, I guess, is to remove oil from the slack wax in order to make the paraffin wax. So start with that. You heat up the slack wax and mix it with one or more solvents. It's most common to use one solvent, and usually it'd be ketone, but there are also cases where someone could do it with a couple solvents. And after you mix everything together, you leave the solution out to cool. And the point of this is to get the wax to crystallize, and which leaves the oil at the bottom of the solution and it separates everything out. I found this little fact as I was researching all of this, but the lower the percentage of oil in the wax, the more refined it is. And the whole product wax is like the crystallized part is the paraffin wax. And the hydrocarbon that actually makes up this crystallized paraffin wax is C31H64. This is a pretty long chain of hydrocarbon molecules, and because it's so long, you can see different properties and behaviors that it has. For example, a chain like C20 and above, like the paraffin wax, would be solid at room temperature, while chains very small, like C5, C6, and C7, are very light and liquid at room temperature. Because how long the hydrocarbon chain is, it also has a very high melting point. And interestingly, I found this as well, but kerosene, which is used in diesel fuel, has a shorter chain length than paraffin wax, ranging from C12 to C15, which I just thought was surprising because I would assume that diesel fuel would just have stronger bonds than candle wax. But I just thought that was a little interesting fact. There isn't really a deep meaning behind why I chose to research candles, but as I was choosing a topic to research and talk about, I just was looking over at the few candles I have in my room, and I was just thinking, like, what happens to the wax when it burns? I don't even know. I have never thought about that before, and as I looked more and more into it, I became more interested because crude oil used to make wax is also used to make fuel, which I just thought they were never even related. But I ended up learning a few things that I thought were interesting, and it also helped me learn more than just beyond candle wax because of the bond lengths of the hydrocarbons and how you can use those to do different things.